Hi everyone! Today I'm going to be going over LeetCode problem number 328, Odd Even Linked List. The key takeaway for this problem is practice with pointer manipulation. So if you want to get some extra practice with manipulating pointers in a linked list, this is a problem for you. Alright, let's go ahead and get started. Again, this is problem number 328, Odd Even Linked List. Given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. The first node is considered odd, and the second node is even, and so on and so forth. Note the relative order inside both the even and odd groups should remain as it was in the input. You must solve the problem in O of 1 extra space complexity and O of n time complexity. Okay, so the O of 1 space complexity means we can't just create another linked list. We have to solve the problem by manipulating pointers and modifying the linked list in place. So now let's look at the examples they give. The first example has an input of 1, 2, 3, 4, and 5, and the output is 1, 3, 5, 2, 4. So the nodes with the odd indices, 1, 3, and 5, are put in front of the nodes with the even indices, 2 and 4. And the order within the odd and even nodes are preserved. So the 1 is still in front of the 3, which is still in front of the 5, and same with the even list. The 2 is still in front of the 4. In the second example, the input is 2, 1, 3, 5, 6, 4, 7. And the output is 2, 3, 6, 7, 1, 5, 4. So this is a good example where the numbers in the original input are not the same as the indices. In example 1, the value was the same as the index. So the first node had 1, the second node had 2, etc. But that's not the case with this input. So if we were to write out the indices of the input list, it would be 1, 2, 3, 4, 5, 6, 7, and we can see that the odd number indices are still in front of the even numbered indices. So the 2 has an index of 1, the 3 has an index of 3, the 6 has an index of 5, and the 7 has an index of 7. And then the 1 has an index of 2, the 5 has an index of 4, and the 4 has an index of 6. So the odd numbered indices are still in front of the even numbered indices. Alright, these are some pretty good edge cases. One question I would maybe ask is what happens if the linked list is empty? So if we look at the constraints at the bottom of the problem, it says n is the number of nodes, and n can be 0. So I would add in that test case. Given the input of an empty list, I think we would just return an empty list, but I would ask the interviewer just to make sure. Another thing I'm noticing in these test cases is that they all have an odd number of nodes. A solution that works on an odd number of nodes might have a different termination condition or would error if it also had to work on an even number of nodes. So let's add in a test case with an even number of nodes, just so that we can ensure our code works even when there is an even number of nodes. So let's add a test case with an input of 5, 2, 3, and 1, whose expected output is 5, 3, 2, and 1. So the 5 has an index of 1, the 3 has an index of 3, the 2 has an index of 2, and the 1 has an index of 4. Okay, with these test cases created, let's get started with our plan. Alright, so really we're building two sublists. One list with the nodes with the odd indices, and another list with the nodes with the even indices. So let's create two variables to keep track of the head of each sublist. Let's call the head of our odd indices list odd head, and the head of our even indices list even head. Odd head is initialized to the first node of our linked list, and even head is initialized to the second node of our linked list. Then, let's create two more variables, odd tail and even tail, that we're going to use to build our odd list and even list off of. Unlike odd head and even head, these variables are going to be updated as we continually build our list. Odd tail is initialized to odd head, the first node of our linked list, and even tail is initialized to even head, the second node of our linked list. The next step is to add the next node with an odd index to our odd list. In other words, we set oddtail.next to oddtail.next.next. Then we add the next node with an even index to our even list by setting eventail.next to eventail.next.next. Then we update our odd tail and even tail variables. And we repeat the process of adding new nodes to our sublists and updating our variables until we can't anymore. In this case, we stop because the even tail has been updated to none. Now we have to connect our two sublists. Since the odd list comes before the even list, we set oddtail.next to even head. And finally, we return odd head. Alright, so here's the full plan written out. Another thing we should be aware of is possible errors. We can't access a node's next property if the node is none. So in step 1, we should first check that head is not none before creating our even variables. And in step 2, we should verify that oddtail.next and eventail.next are not none before accessing oddtail.next.next and eventail.next.next. Okay, now that we have a solid plan, let's get coding. I've copy-pasted our plan into our text editor so we can use it to code up our solution. So the first step of our plan is to check if the head is none, because if the head is none, we can't create all the variables that we need. So let's take care of this edge case. If head is none, then we just return the head. Alright, next we need to create the variables. So let's create odd head, odd tail, set it to the first node of our list, and create even head and even tail, and set it to the second node of our list. Okay, and the next step is to add another node to our odd and even sublists, if we can. Let's start with the odd sublist. So first we add an if condition to check if there even is another odd node to add. And if there is, we set oddtail.next to oddtail.next.next. And then we do the same thing for the even sublist. And then we update the odd tail and even tail variables to the new tail of the odd list and tail of the even list, which are the nodes we just added. And the next step in our plan is to repeat until we can't anymore. So let's move our if conditions to a while loop. And then we connect our odd list to our even list by setting oddtail.next to even head. Finally, we can return odd head. Okay, this code is looking pretty good. But let's do a run through with one of our test cases just to make sure it doesn't have any bugs. So we made our plan using the first example with an odd number of nodes. So let's do a run through on a test case with an even number of nodes. So the input is 5, 2, 3, 1, and the expected output is 5, 3, 2, 1. Okay, so initially, odd head and odd tail are 5, and even head and even tail are 2. We set oddtail.next to oddtail.next.next, so we set 5's next node to 3, and then we set eventail.next to eventail.next.next, so we set 2's next node to 1. Then we connect the two lists by setting oddtail.next to evenhead, and so we connect our oddtail, 3, to our evenhead, 2, and we get our expected output, 5, 3, 2, 1. Alright, now that we're pretty sure our code works, let's run it through all our test cases. And hooray! Looks like we're passing all our test cases. So let's go ahead and evaluate the time and space complexity of our solution. So the time complexity is O of n, or linear, since we pass over each node once as we're adding it to our odd or even sublists. And the space complexity is O of 1, since we're only using a constant number of variables: odd head, odd tail, even head, and even tail. Alright, that's it for today's problem. The key takeaway was practicing our pointer manipulation skills. So focus on that when you're doing this problem on your own or reviewing it. Hope this video was helpful for you, and thanks for listening.